tour guides. I'm Jenny.
I'm Sandy.
I'm Chandler.
And I'm Sausan.
And we're going to be talking to you about your resort in Iceland.
Hi, I'm Jenny, and I'm going to be talking to you about Iceland's geology. Some of you may know that Iceland sits atop the Mid-Atlantic Ridge. It also sits on top of a hot spot. The Mid-Atlantic Ridge is at a divergent boundary, so there is tension, which contributes to the local volcanoes and earthquakes. Iceland was formed by the spreading of the North American and Eurasian plates. As the plates moved apart, it created a rift valley, which volcanoes that erupt fill with lava. Iceland is being diverged because of tension, but it is not equal on both the north and south side of the island. The north divergence started 150 million years ago, and the south divergence started 90 million years ago. So basically, the north is farther apart than the south, meaning the sides are not equal from the north versus the south. These movements of the plates have multiple effects, like creating earthquakes, causing old volcanoes to erupt and new volcanoes to be created. This area is very explosive, and the volcanoes erupt frequently. That means there's a lot of heat and pressure in the area. Iceland is the largest island on the ridge due to the hotspot that is located underneath the country. Iceland is slowly moving towards the northwest across this hotspot. The Azores, Bermuda, Madeira, the Canary Islands, Ascension, St. Helena, and Tristan da Cunha are other islands that are formed by the volcanism of the Mid-Atlantic Ridge on the Atlantic coast. These islands, however, are not as explosive as Iceland is. The plates that are pulling apart the country move from east to west, and both the North American and Eurasian systems move to the northwest across the hotspot. Some things to know about Iceland is that it has more than 100 volcanoes, 25 of which have erupted in recent years. Iceland also has 20 to 100% molten layer at the depth of 5 to 20 kilometers, which supplies sufficient material for eruptions. Iceland is constantly forming new crust because of the divergent boundary, but the most active area of new crust formation is found in the southwest part of Iceland. I hope that you have learned some new things about Iceland's geology. Now I'll give you to Chandler, who can teach you more about the wonders of Iceland.
Hi there, tourists. I'm Chandler, and I'm going to be talking about the level of seismic activity and volcanic activity in the Icelandic area. About 79% of Iceland's land area consists of glaciers, lakes, mountainous lava deserts, and other wasteland. The highest elevation is 6,590 feet above sea level in Iceland. The seismicity of Iceland is very high. We know this because there are many earthquakes occurring each day in Iceland. Iceland's huge level of seismic activity comes from two sources. One, Iceland is on top of a hot spot, and two, the Mid-Atlantic Ridge runs right down the middle of the country. Iceland is one of the world's most volcanically active places. Volcanoes are like the building blocks of Iceland, constantly erupting and adding to its landmass. Here are some pictures that show you how massive these volcanoes and the Mid-Atlantic Ridge are. One of the most famous volcanoes is which just erupted this year, shutting down most airports in Europe and northern countries because of all the ash sent into the air by its eruption.
Hey! I'm Sausan, and I'm your tour guide who's going to tell you all about how forces, waves, and energy affect Iceland. The Mid-Atlantic Ridge is separated by the North American and Eurasian plates. Iceland is being pulled apart due to these plates. This is caused by a divergent boundary, which is when two plates move apart from each other. This space is filled with new crustal material formed by magma. This is called seafloor spreading. The force that causes divergent boundaries is tension, which is caused at normal faults. Divergent boundaries can create massive fault zones in the oceanic ridge system. Tension is when two plates are moving away from each other. Because of the seafloor spreading, transform faults occur. Now guess what occurs at transformed boundaries? Earthquakes! glide past each other. Because of friction, the plates cannot glide past each other easily. When stress exceeds static friction, potential energy is released as strain. Earthquakes occur due to this strain. Stress is the pressure put on the tectonic plates that cause them to move. At these faults, the forced shear causes the plates to twist. Earthquakes occur when energy stored in the earth, usually in the form of strain, is suddenly released. The energy is transmitted to the surface of the earth by earthquake waves. There are three types of waves: P and S waves and surface waves. P waves are compression waves that cause rocky material to move back and forth, causing the rock to compress and expand. Compress, expand, compress, expand. S waves are shear waves that twist the rocky material and cause rocky material to either move side to side or up and down. Side to side, down, up and down. S waves, surface waves cause these particles to move forward, backwards, up and down. The sudden movement of rock along a fault causes vibrations that transmit energy in the form of waves. Of course, in Iceland, not only do earthquakes occur, but volcanoes as well. The reason volcanoes erupt is due to energy. You see, as pressure builds inside the volcano's magma chamber, potential energy increases as gas bubbles try to escape. As gases apply force to the rock inside the magma chamber, gases push magma to the surface, which allows potential energy to become kinetic energy, thus causing volcanic eruptions, such as
Hey there, everybody. You've learned a lot about Iceland today, but I'm going to talk to you about the potential hazards. Iceland, as you know, is formed on a divergent boundary, which through compression and tension creates shield volcanoes. Shield volcanoes have faster moving lava than other types, like cinder cone volcanoes do, so their lava can spread very quickly. Because the lava moves so quickly, it can reach many places of business, homes, and wildlife. In Iceland, volcanic activity has repeatedly affected the population. Consequences range from direct impact of tephra and lava to contamination of water and crops. Not only that, but Iceland experiences eruption plumes of 8 to 15 kilometers. They can cause disruption to air traffic. Chemical compounds that come out of an erupting volcano stick to the surface of the tephra particles and cause water pollution. This is poisonous to livestock and has killed thousands of people in past eruptions. Pyroclastic flows are another type of chemical that have the ability to burn down a whole town. Lava flows are also common. Property loss has been common due to eruptions and is even increasing. But other hazards include earthquakes, faulting, damming of river by lava flows, and tsunamis.
Hello, I'm going to be talking to you about mechanical weathering, chemical weathering, and erosion in Iceland. Chemical weathering caused by CO2 pressures are higher in places that have vegetation versus barren places. CO2 chemically reacts with water to form carbonic acid. An example of carbonic acid is how it dissolves limestone to form caves. Chemical weathering is a chemical reaction between rocks and water that result in the formation of a new substance. A type of mechanical weathering is when the temperature increases so high, like if they're in or under lava, that the rocks try to cool rapidly and start contracting, and it could break as a result. Animal weathering has to be mentioned as well due to the vast amounts of animals that kick the ground, and the rocks to have some effect in the picture of mechanical weathering. Mechanical weathering uses the forces of kinetic energy when it's transferred into rocks in a river. Erosion in Iceland is in deserts. The deserts are near many volcanoes. Also, landslides cause rapid erosion. This is causing loss of vegetation. Many deserts in Iceland are formed by erosion. Volcanic ash and glacial rivers make up this sand. It travels long distances before it finally settles in the desert. This erosion is happening rapidly and causing desert encroachment. The particles have potential energy that get changed into kinetic energy.
Hey, it's Sausan again. Have you heard what's been happening in Iceland? That's right. Has been erupting since March 2010. That's right, it's still erupting. Scientists predict that won't stop until May 2011. Last time this volcano erupted, it lasted for 14 months, erupting from December 1821 to January 1823. Zowie! Small earthquakes are happening underneath the volcano, suggesting that volcano still has it in it. The swelling of the volcano, measured through global positioning systems, can also provide hints of how long it will erupt. As I explained before, the erupting volcano and volcano prediction was predicted by the help of seismometers, which pinpoint the earthquake's exact activity, also measuring the volcano's swelling, providing additional information about the volcano's magma and its activity. This prediction is very good, especially because we have already experienced the damage of the volcano, and because scientists have been predicting this eruption using the advantage of the earthquakes and gas releases. But is it a one-in-a-lifetime experience? Iceland has been experiencing volcanoes and earthquakes for years. In fact, Iceland is made up of volcanoes.
Hello, I'm Sandy, and I'm going to be talking to you about possible resort attractions. There are many fun activities you can do in Iceland. One activity is you can go hiking near one of our many volcanoes. Or you could take a journey near the Mid-Atlantic Ridge. Another activity you can do is go swimming in natural-made geothermal pools. These pools are heated by magma under the surface. Also, there are many rivers in Iceland, many perfect for river rafting. One of the rivers in Iceland is there are many faults and volcanoes in Iceland. I'm going to show you what they are and what evidence we have to support what kind of fault or volcanoes they are. There are large strike slip faults that we know of because they create earthquakes that reach M7 to 7.5. This type of fault is in northern Iceland and is controlled by shear stress concentration. Also, there is a divergent boundary that goes through the center of Iceland. This is called the Mid-Atlantic Ridge. The North American and Eurasian plates are spreading apart at divergent boundaries. This is an example of continental drift. Convection is helping move these plates. There are shield volcanoes that produce basaltic lava flows, such as the There are also stratovolcanoes, such as the They all have explosive eruptions. These are the most destructive due to high viscosity and high gas buildup. Stratovolcanoes are formed by compression and subduction zones. Volcanoes are created by compression and tension. But when volcanoes erupt, the potential energy is released and changed into kinetic energy.
I used to rule the world. Seas would rise when I gave the word. Now in the morning I sleep alone. Sweep the streets.